So for question number 3, which gives us a graph of f, I can see that we have 3 line segments, and it is called the graph of f. So this is the last question of, well, the first question of no calculators. So let's go ahead and read what the question is asking us, or telling us. The function f is defined on the closed interval -5, 4. The graph of f consists of 3 line segments and is shown in the figure above. Let g be the function defined by g of x is equal to the integral from -3 to x of f of t dt. Part A, find g of 3. So part A, if you remember by regular function notation, all you do is plug in 3, which would give us the integral from -3 to +3 of f of t dt. So we're looking for the area underneath the curve from here to here. Now, because if you remember, the most basic definition of the integral is area underneath the curve, and if it's above the curve, above the axis, it's a positive area, and if it's below the axis, it's a negative area. So let's go ahead and get started with this. I see a big triangle right here, so let's go ahead and find this entire area. This will give us the area from -3 to +2. So the base is 1, 2, 3, 4, 5 units wide, and the height is 1, 2, 3, 4 units high. Using the area of the triangle, we would have 4 divided by 2, which is 2. 2 times the base 5 is 10. So the area of this entire triangle is 10. Now we need to find the area of this triangle, which goes from x equals 3 all the way down to a value that we can assume to be -2. However, let's confirm this by using slope formula, because we do have 2 points. We have the point 0, 4 and 4, -4. So using 2 points 0, 4 and 4, -4, slope formula, we get -4 minus 4, which is -8, all over 4 minus 0, which is 4. -8 divided by 4 gives us -2. This is the slope of this line. Now, by using point slope form of the first point, because it has a 0, we get y minus 4 is equal to -2 times x minus 0, or just x. Adding 4, we get y is equal to -2x plus 4. This is the equation of this line. Now, by plugging in the value x equals 3, we get -2 times 3, which is -6, and -6 plus 4 gives us -2. This confirms our rough estimate of the x value of 3 equaling -2. So now that we know that's equal to -2, we can find the area of this triangle. So the base is 1 and the height is 2. So we would get 1 times 2, which is 2, divided by 2 is 1. Now, because this area is beneath the curve, the area of this triangle is actually -1. And now that we just found the area from -3 to 2 and 2 to 3, we can combine them to find the integral from -3 to 3. 10 minus 1 is 9. So that gives us the answer to part A. G of 3 is equal to 9. Part B. On what open intervals contained in -5 through 4 is the graph of G both increasing and concave down? Give a reason for your answer. Now, it's asking us for the graph of G, but look, we have the graph of F. However, the very last part of the information they give us, they tell us that let G be the function defined by g of x is equal to -3, the integral from -3 to x of f of t dt. If we take the derivative of g of x, we would get the fundamental theorem of calculus, which is you just basically plug in this limit of x into here and multiply by the chain rule if needed, and in this case, since it's just an x, it's not needed. So we actually get that g prime of x is equal to f of x. This is significant because now this tells us that the graph of f is also the graph of g prime. And this is important because if you remember, whenever we're looking for a graph and we're looking for its intervals where it increases or decreases, or its concavity, we need the derivative and the second derivative respectively. Now, by actually looking at the graph of a derivative, we can actually find both increasing and decreasing and concavity. Since this is also the graph of g prime, this tells us that this is the graph of g prime. I just said that. But since this is the graph of g prime, all the values where this is above the axis, so all the positive y values, we have a positive slope. All the values where the y values are below the axis, we have a negative slope. So, for example, from the interval -5 all the way to 2, we have a positive slope. Well, neglecting -3 and 2 because those are a slope of 0. So, basically, the positive values give us positive slope, the negative values give us negative slope. And of course, these 2 points where they equal 0 gives us a horizontal slope or a slope of 0. Now, for concavity, if we're looking at the graph of a derivative, concavity is determined by looking at the graph and looking at points of increasing versus decreasing. So, for example, if we were to look at the interval -5, which is right here, all the way to the interval -3, which is right here, the graph of g prime is decreasing, which makes it concave down. Now, since the values are positive, this means that the slope is positive. But since the graph of g prime is decreasing, since the slope is decreasing, that makes it concave down. Sorry for the pause there. So, by looking at this, we can tell that the two places, the two intervals, where graph of g is both increasing and concave down, would be wherever the values are positive and wherever they're decreasing. So, by looking at this graph, I know that it's from -5 to -3, and from 0 all the way to 2. Because, again, the values are positive and they're decreasing. So the answer to part B would be from -5 to -3 and from 0 to +2. Now it also asks give a justification or give a reason. And the reason would be since the graph of f, or since f is equal to g prime, since f is equal to g prime, well, not since actually, let's say the graph of f is equal to the graph of g prime. On these intervals, g prime is both positive and decreasing. So that would be the justification for part B. Let's move on to part C. The function h, so now we're introduced to a new function, is defined by h of x is equal to g of x all over 5x. Find h prime of 3. So let's do just that. First, we need to take the derivative of this. So h prime of x is equal to, now this is the quotient rule. So if you remember, it's the derivative of the top, which is g prime of x, times the bottom, 5x, minus the derivative of the bottom, which is 5, times the top, which is g of x, all over the bottom squared, which would be 25x squared. It's asking us to find h prime of 3. So let's just plug in 3 for x and let's see where we go from there. Now, g prime of 3, let's compute this first actually. Let's plug in 3 for all the x's that stand by itself to clean this up a bit. So if we plug in a 3 right here, we get 15, 5 times 3. So let's rewrite this as 15 g prime of 3 minus 5 g of x all over, if we plug in 3 for here, we get 9. 25 times 9 is 225. Now, let's actually look let's look for the values of g prime of 3 and g of 3. Oh, I'm sorry. I wrote g of x here. We plugged in 3. This should be a 3. So looking for the values of g prime of 3 and g of 3. For g prime of 3, we have, remember, this is also the graph of g prime. So when we plug in 3, we're literally just looking for the y value. And in part A, we already found this y value. The y value of g prime of 3 is negative 2. So 15 times negative 2 is negative 30. Minus 5 times g of 3. Now, we already found g of 3. That was the answer to part A, which is 9. So minus 5 times 9, which is 45, all over 225. That is equal to negative 75 all over 225, which reduces to negative 1/3. Oh, that cleaned nicely. Came out nicely, I mean. So the answer to part C is negative 1/3. Part D. The function p, another function, is defined by p of x is equal to f of x squared minus x. Find the slope of the line tangent to the graph of p at the point where x equals negative 1. So we're just looking for the slope, so we actually don't need to plug in negative 1 anywhere to find the y value. We just need to plug in negative 1 to the derivative of p of x. So let's take the derivative of p of x. So p prime of x is equal to f prime of itself, so x squared minus 2x, x, times the chain rule, which would be of what's inside, which is 2x minus 1. We're looking for p prime of negative 1, because it tells us where x equals negative 1. So p prime of negative 1 is equal to f prime of negative 1 times negative 1 is 1. 1 minus negative 1 would be positive 2. 2 times negative 1 is negative 2. Negative 2 minus 1 is negative 3. So p prime of negative 1 is f prime of 2 times negative 3. I should write this in front so it doesn't look like anything, so it doesn't look like a minus 3. Alright, so f prime of 2. Now we have the graph of f, so f prime would be the slope at the point x equals 2. So at x equals 2, we're in the middle, we're in between the intervals 0, 4 and 4, negative 4, which is a line which has a constant slope. Now for part A, we already found the slope of this line to confirm the height of the second triangle. The slope is negative 2. Is negative 2, which is right here. I picked the wrong negative 2. That was a coincidence. So we have negative 3 times negative 2, which is equal to positive 6. And that gives us the answer to part D and concludes this question number 3.